We will loosely consider a sequence to be a list of numbers. For example, I'm hoping you recognize this particular sequence. We sometimes refer to this as our Fibonacci sequence. And I think you can tell what's really going on. We're starting off with these two seeds, but we add these two numbers together, you get the third item on my list. Add these two, you get the next item on my list. Add these two, you get the next item. So there's a Fibonacci sequence. Now, notationally speaking, I might think of the first term as a sub 1. So a sub 1 is equal to 1. A sub 2 is equal to 2. A sub 3 is equal to 3. And so sometimes more generically, I might use this notation to refer to a sequence. Or how about this? Sometimes I will just talk about an arbitrary nth item in the sequence and put braces around it. To be really clear what values that index variable holds, I sometimes even declare that I have these extremes. Now, I know that you are already familiar with two types of series, or excuse me, I misspoke, two types of sequences. So how about an arithmetic sequence? Here's a list of numbers that has the following quality. If you can read that. Notice how the difference between any two consecutive elements in my sequence is the same. I have a common difference. This is why back when you studied pre-calculus, you made a declaration that an explicit formula for the nth term can be described as saying something like, well, it's nothing more than maybe the first item we have, increased by n minus 1 times that common difference. Or recursively, you would say that your nth term is nothing more than its predecessor, increased by the common difference. Whereas with a geometric sequence, I might have something like a 3 and then maybe a 6 and maybe a 12, maybe a 24, and you can see the pattern. It may not be the case that I've got a common difference between any two consecutive entries like I do with this sequence, but I do have a common ratio. This element divided by its predecessor is 2. But this entry divided by its predecessor is the same. That item divided by its predecessor is the same. And of course, explicitly declared in the past that the nth term can be explicitly described by the first one times that common ratio raised to 1 less power than your position in the sequence. Or recursively, you said that a sub n is equal to nothing more than its predecessor times that common ratio. Now, I gotta admit, when it comes to describing a sequence recursively here and here, you did have to stipulate, in addition to that, what the very first entry was. Pound symbol just being whatever that number is. So there's our introduction to sequences. I have a lot to discuss. I want to discuss monotonicity, boundedness, actually convergence of sequences. So I'm afraid for this one section, I do have an awful lot to say.